In today's video, we will be talking about gravity. After watching this video, you should be able to understand the relationship between distance and the acceleration due to gravity. So some of the concepts that we're going to be talking about in this video, you'll say, man, this is nothing new. And that's true. Some of this stuff we have talked about before, but now we're just going to look at a little bit more in depth in terms of gravity, how we kind of figured out that it actually existed, and how we measured it. Okay, so let's get right to this video. Just a little bit of history so you kind of have an idea where this is coming from. This guy named Johannes Kepler developed 3 laws to describe the motion of planets about the sun. And basically the laws emerged from just analysis of data over many, many years. This was not something that happened real quickly, and some of the data was used from Johannes Kepler's mentor, if you will, Tycho Brahe. So those are 2 relatively prominent figures in astronomy. Anywho, they were interested in looking at the motion of these planets about the sun, and basically Kepler came up with these 3 laws that we'll talk in a lot more depth about in a couple lessons. But for right now, I'll just kind of give you a quick rundown on the 3 laws. The first law basically says is that all the planets orbit the sun in an elliptical shape. So instead of a perfect circle, it's kind of like a stretched out circle. It's called an ellipse. The second law basically says that a planet sweeps out equal area in equal amounts of time. And again, we'll go into much more detail into those later on. And the third law basically says that the orbital period and radius of one planet is comparable to the orbital period and radius of another planet. So when you compare 2 planets to one another, there is a relationship that exists between them. Okay, so keep that in mind. Anyway, this guy named Isaac Newton came along. And he was looking at Kepler's laws, and he was frustrated by them because he could not, basically Kepler could not explain how come the planets follow these 3 laws. What was causing them to orbit the sun in that fashion? And basically a breakthrough came when Newton was just 24 years old in an apple orchard in England. And the story goes that basically that Newton was struck on the head with an apple, and that basically gave him the idea that he needed to kind of come up with this idea that, hey, maybe this thing called gravity caused the apple to fall on my head. And so he came up with this idea called the universal law of gravitation. Okay, so universal law of gravitation. All right, so let's kind of take a look at what Newton started thinking about. So, you know, we all have heard probably the story before of Newton getting hit in the head with an apple. Newton started to kind of think about this idea that maybe if this was the Earth, and let's say we stuck a cannon on the top of the Earth, and I am not a good drawer, but let's say we stuck a cannon on top of the Earth, and we were shooting cannonballs off the top of the Earth, and we were shooting at various speeds. So let's say we fire one, and it kind of comes off like this, and then it hits the ground. Okay, and I wish I was a better drawer than that, but let's say one did that. And then we shoot another one a little bit faster, and it goes and it falls and hits the ground. Okay, now let's say this time we shoot it so fast that the speed at which it falls towards the Earth basically matches the curvature of the Earth. So let's say it kind of goes like this. Okay, it's so fast that it actually falls and matches the curvature of the Earth. Well, that's called going into orbit, and that's actually what a cannonball would do if you could shoot it fast enough. What the moon does is it orbits the Earth, and really what the planets are doing as they orbit the sun. Okay, so basically, as you increase the velocity of an object, as you shoot it, at one point it gets to a high enough velocity that it would start to actually orbit the Earth. And this is how we put satellites into orbit, like these. I don't know if you guys have heard of cell phones, but your cell phones typically connect to a cell tower, which then probably connects to a satellite, and then uses information to be spread through the satellites that are orbiting the Earth. The same thing works that way, or the same way. The same thing is true of GPSs, that there's satellites orbiting the Earth, and your GPS locks into, I believe it's 4 satellites is necessary to basically figure out your location. Let's say you shoot it even faster yet. what ends up happening actually is it orbits in an elliptical shape, and this is what an ellipse looks like. It's kind of an oblong looking shape. So if you shoot even faster than that, basically it would orbit in an elliptical shape, and that's actually kind of how the moon orbits the Earth. It's more of an elliptical shape than a perfect circle. If you shoot even so fast, you actually can escape Earth's gravity, and that's kind of like what spaceships do in terms of when they want to get outside of Earth's gravitational pull, they have to travel fast enough to escape Earth's gravity. But that really goes beyond the point of the story. So the point is, Newton thought about all this, and he was thinking this is basically what governs all the motion in the universe, is this thing called gravity. And this is basically what the objects are doing, is that they are under the influence of gravity. So Newton came up with this idea called universal law of gravitation. And basically it explained basically all the motion in the universe. And again, this goes back to this idea of this apple falling, hitting Newton on the head, and basically they knew that apple accelerated towards the Earth at a speed of 9.8 meters per second squared, whereas the moon accelerated towards the Earth at a rate of 0.00272 meters per second squared. Notice there's quite a difference in terms of the acceleration of the apple and the acceleration of the moon. And the question became, well, how come there was that difference in gravitational acceleration? Why was that there? And that was kind of Newton's goal, was to figure out how come that was happening. So it turns out that there is this thing called the inverse square law. And basically the inverse square law says that the force of gravity between the Earth and any object is inversely proportional to the square distance that separates that object from the Earth's center. So basically, to make this much easier, the further you are from the Earth's center, the less gravity has its effect on you. Okay, so as you get further and further away, gravity becomes less and less potent or strong. And that relationship, as it's written kind of down here in the bottom, that got a little bit cut off, is basically the force of gravity is equivalent to, and this is kind of about, an about symbol is just a little squiggly, 1 over d squared, d being the distance that you are from the Earth's center. So as you get further and further away from the Earth, and let's say you get all the way out to the moon, the distance is quite great, and so the gravitational effect on the moon is a lot less than, say, us standing right on the Earth's surface. That takes care of this video. I will see you guys next time.